Right now, there are over 8,000 satellites zooming around Earth at 17,000 miles per hour. They're not attached to anything, no strings, no rockets constantly firing, and yet they don't fall. Why don't satellites just drop? Like, what's actually keeping them up there? Because here's the thing, gravity is still pulling on them hard. So what's going on? Today, we're going to crack open one of the most mind-bending ideas in physics. And I promise, once you get it, you'll never look at the sky the same way again. Before we get started, check out the link in the description to download our ebook. First, let's talk about what satellites actually are. A satellite is just any object that orbits around a planet. The moon? Satellite. The International Space Station? Satellite. That little metal box beaming Netflix to your TV? Also a satellite. We've got satellites that help you navigate, predict the weather, make phone calls, study climate change, and even spy on other countries. They've become so essential that if they all disappeared tomorrow, modern life would basically collapse. No GPS, no instant communication, no accurate weather forecasts. But here's what most people don't realize. These things aren't floating in some magical zero-gravity zone. They're falling constantly, and that's exactly why they stay up. Wait, what? Let's start with the obvious problem. You drop something, it falls. That's what gravity does. It pulls things toward the center of the Earth. And guess what? Gravity doesn't stop at the atmosphere. It reaches way out into space. At the altitude where most satellites orbit, say 150 miles up, for the ISS gravity is still about 90% as strong as it is on the ground. So if you took a satellite, held it still at that height, and let go, it would absolutely plummet back to Earth. So why doesn't that happen? Here's where it gets good. The secret is speed. Specifically, sideways speed. There's this famous thought experiment by Isaac Newton. Imagine you've got a cannon on top of a really tall mountain. You fire it. The cannonball flies forward and then falls to the ground, right? Now fire it faster, it goes farther before it hits. Fire it even faster, and eventually something crazy happens. The cannonball is falling toward Earth, but Earth is curving away beneath it at the same rate. So it just keeps falling forever, around and around the planet. That's an orbit. This might shock you, but satellites aren't defying gravity. They're constantly falling toward Earth. They just also happen to be moving sideways so fast that they keep missing it. Think of it like this. If you throw a ball, it arcs and lands. But if you could throw it at 17,500 miles per hour while standing on a platform high above the atmosphere, it would fall around the planet instead of into it. That magic speed, about 17,500 miles per hour for low Earth orbit, is called orbital velocity. It's the exact speed where the curve of your fall matches the curve of the Earth. Gravity is still pulling, you're still falling, but you're also moving forward fast enough that the ground keeps dropping away beneath you. Mind blown. Let's make this real. The International Space Station orbits at about 250 miles up. It's going 17,500 miles per hour. It completes one lap around Earth every 90 minutes. The astronauts inside feel weightless, not because there's no gravity, but because they're in constant freefall. They're falling, the station is falling, and everything inside is falling together, so it feels like floating. GPS satellites are way higher, about 12,500 miles up. At that altitude, they only need to go about 8,600 miles per hour to stay in orbit. Why? Because gravity gets weaker the farther out you go. The weaker the pull, the slower the required speed. And then there's geostationary orbit, about 22,000 miles up. At that height, a satellite takes exactly 24 hours to complete one orbit. Since Earth rotates once every 24 hours, the satellite appears to hover over the same spot. That's how your TV dish can point at the same patch of sky and always get a signal. Different heights, different speeds, same principle. Fall forward fast enough and you'll never hit the ground. All right, let's bust some myths. Myth number 1, satellites float because there's no gravity in space. Nope, gravity is everywhere. Even the moon, 240,000 miles away, is held in orbit by Earth's gravity. Satellites aren't escaping gravity, they're dancing with it. Myth number 2, rockets have to keep firing to hold satellites up. Also know, once a satellite reaches orbital velocity, the engines shut off. There's no air resistance in space to slow it down, so it just keeps going. Forever. Well, almost forever. More on that in a sec. Myth number 3. You need to be far enough from Earth for orbit to work. Not exactly. You could orbit just above Earth's surface if there were no atmosphere. The problem is air resistance. Below about 100 miles, the air is thick enough to drag on a satellite and slow it down. Once it slows below orbital velocity, it falls for real. But here's the weird part. Technically, with enough speed, you could orbit at any altitude. You'd just need a lot more speed, closer to Earth, and you'd burn up from air friction. So what happens if a satellite does slow down? It's called orbital decay. Even in low Earth orbit, there are a few stray air molecules. Over time, they create tiny amounts of drag. The satellite slows down just a little, and when it slows down, it falls into a slightly lower orbit. Lower orbit means thicker atmosphere. Thicker atmosphere means more drag. More drag means it slows down even more. Eventually, it spirals inward and burns up in the atmosphere. That's what happens to most satellites at the end of their lives. The ISS actually has to fire its engines periodically to boost itself back up because it's slowly falling. Most people don't realize it, but the space station is constantly being nudged back into place. Without those boosts, it would crash back to Earth in just a few years. So here's the beautiful thing. We've built a shell of technology around our planet, a layer of metal and circuits falling in perfect circles, fast enough to miss the ground forever. Every second, these machines are threading the needle between too slow and too fast, between falling and escaping. And it all comes down to one elegant idea. You don't fight gravity, you work with it. Satellites have connected the world. They've saved lives. They've shown us our planet from a perspective our ancestors could never imagine. And they do it all by falling. Next time you check your phone's GPS or stream a video, remember, somewhere overhead, a metal box is screaming through the void at 17,000 miles per hour, locked in an endless dance with gravity. And that's pretty incredible. If this blew your mind, hit that like button. It helps more people discover how wild physics really is. Subscribe if you want more science explained in ways that actually make sense. And drop a comment. What do you want to see explained next? Thanks for watching. Keep looking up.